Okay, so the last part of 1.1, just a few quick equations we're going to do. We're going to look at piecewise functions real quick. We've got a piecewise function here. Remember, our domains are right here, so we pick where our x fits in. So we're going to do f of negative 1. We're going to do f of 0. And we're going to do f of 1. So, negative 1, does it fit in the top equation or the bottom equation? The top, because it is less than 0. So, negative 1 squared plus 1 is 2. Now, be careful that you're putting these parentheses, because if you're writing negative 1 squared plus 1, your answer is 0. We've talked about this a lot last year, and you need to watch where those placement, because here we're squaring the 1 and then multiplying it by negative 1. Okay, 0, first equation or second equation? Second, because it's equal, right? Mm-hmm. So 1 minus 1 is, or 0 minus 1 is?
Negative 1.
Okay, 1, where's it at? Second 1. So it's 1 minus 1, so I get 0. Can these domains be like, could I have x is less than negative 6? Negative 6 is less than equal to x, which is less than 4. And 4 is less than equal to x, which is less than, actually, 4 is less than equal to x. Can I have 3 equations?
Yeah.
And 3 different conditions?
Yeah.
Yep. And you just pick where your x falls into the domain, correct? Mm-hmm. Okay. Questions? So, finding where it is equal to 0. Again, this was on yesterday's, but you should have known how to do it. So it says f of x equals 0, so you set it equal to what?
0.
0. So 0 equals negative 2x plus 10.
You move over the 10, divide by
So subtract the 10, divide by negative 2, and x equals 5. Guys, when you show me work, writing the problem, this and this, that's as much work as I need. Okay? I don't need a bunch. If you want to show more, that's fine, but those of you who are adverse to showing work, I need at least this much. You know why I'm looking at you, Matthew.
Am I the only one?
And I'm looking at Bladen through the TV screen, through his computer screen. I'm looking at him.
Oh, yeah.
Okay, so next one, I set it equal to 0. It is quadratic. In order to solve a quadratic, we always have to set it equal to 0, yes? So if we had other things, yes, Cadence, and we must factor. So the factors of 6 that add to 5 are 3 and 2, and they're both negative. And then you set both of these equal to 0, and so x equals
2 and 3.
2 and 3. Now 3 and 2 is right, but we should always try to put them least to greatest. So when we graph things, we have them in order. Okay? Now, we did review this. We did all this on that other worksheet, right?
Yep.
But your directions were different, weren't they? So in this textbook, a lot of times, you guys know exactly what you're doing. It's the directions that you need to stop and say, okay, I know what I'm doing. What is it really asking me? They put a lot of math verbiage in their directions. It's not a plain, simple slap you in the face. You have to know the terminology to know what to do. So just when you're reading a problem and you get all freaked out, just stop and think a second. Okay, Mrs. Mick had to have showed me how to do this. Okay, what do my directions say to do here?
Get f of x equal to g of x.
So f of x equal to g of x. So what do I have to do with the 2?
X squared plus 1 equals 3x minus x squared.
Okay, so x squared plus 1 equals 3x.
Whoa.
Can you still see it? Why I'm messing? Okay, so I just set them equal to, I already have mine written, so, haha.
Disrespect.
Okay, so it's gonna be quadratic, yes? So I need to set it equal to what?
0.
0. What?
Never mind. I thought that you already had it
Oh,
like that, and I was like, we're kind of missing.
no. Okay, so I'm gonna add everything. I'm gonna move it that way. How about you guys?
I don't know if I did.
So you have 2x squared minus 3x plus 1.
That's what I got.
And I need to do what then?
Factor.
So factors of 2 that add to 3.
-2, -1.
So -2. And then set both of them equal to 0. And x equals what? Add the 1 divided by 2 is 1/2. And add the 1 is 1. If you notice, even since the beginning of the year, have I ever wrote that out when I'm solving it? I just said add it over, divide, and I write my answer, don't I? I might write an answer and then reduce it, but we need to move towards only writing what we need to write, because if you write every single thing, you're going to be writing forever on these problems, correct? Okay, what do I have to do with the next one? Set them what? Equal. So -x squared plus x plus 2 equals x squared minus 1. Now I need 2.
Hold on, I'm still writing this problem.
Move the other one over.
Move everything over. We're going to move it all right.
Yeah.
Okay, so what did I get? 2x squared minus x minus 3.
Yeah.
So now I need factors of 6 that have a difference of 1,
3 and 2.
3 and 2. So -3, positive 2. You do your factoring, I'm doing mine. Whatever method you use, it needs to be efficient and accurate.
Why'd you write 1 instead of 2? Never mind. Never mind.
This is what it should factor to.
I know. I remember
Okay.
it.
If you want to spend some time with me learning how to do factor this way rather than doing the grouping when you do this, let me know. I'd be happy to do that with you. Not that I don't group. When my numbers are bigger, I tend to group because it's just quicker. I don't have to think as much. But this isn't a hard way to factor. Did you get 2x minus 3 and x plus 1?
Yeah.
So I set them now both equal to 0. So x is going to equal -1 and 3/2. You didn't have these yesterday, did you? You just had the equal 0. Okay, so you have these today. And then you have 2 application problems. Now, I didn't go over any application problems, but do you think it uses everything that you've done? Yes. Okay, so they're there to stretch your brain a little. Build the muscle.
So, do homework.
Yep, homework.